In a recent video, I showed you how to encrypt files on your Mac using the built-in encryption functions inside the Mac OS operating system. Well, I no sooner finished filming, editing, and posting that video when I stumbled across an article that said, and I quote, "A team of researchers have discovered a serious issue with Apple's M-series chips used in Mac computers. This problem allows attackers to steal secret keys used for encryption from Macs during common security operations." Not good. The flaw is built into the design of the chips themselves, so it can't be easily fixed with a software update. Instead, it requires changes to how cryptographic software is written, which could slow down the performance of Mac computers, especially older models like the M1 and M2. Those aren't actually, I'm recording this on an M2 Mac, which I consider not older, but okay, the M3 is out, but so recent Macs. The article goes on, blah, blah, blah. It takes advantage of what's called a data memory dependent prefetcher, or DMP process, which predicts what the user is going to be needing from the memory, and it goes out and prefetches it. During that process, apparently there's some vulnerability to leaking encryption keys. Not good. Now, this article, originally some people's understandings were that you need to have physical access to the device in order to infect it with this malware that would create a leak of encryption keys. But some security experts say, no, you do not need physical access to the device. Your device is not safe. It simply can be implemented, this attack can be implemented by the user downloading and installing a piece of malware. So I need to reiterate again, you cannot be too careful with the sites you visit, the things you download, the links you click on, and the files that you open, and the applications that you install. You have to be really careful, double, triple check, okay? Now, the article does not, actually I read multiple articles about this problem with this leaking encryption key on the Mac, and the articles do not specifically mention, not one article specifically mentions the AES encryption algorithm, which is the algorithm that we've been talking about in the last video, and I'll talk about in this video. Why am I talking about AES encryption on a Bitcoin channel? Because to me, the most important thing you can do is have self-sovereignty of your Bitcoin. And if you're going to have self-sovereignty of Bitcoin, you're going to produce seed phrases or a seed phrase. And you need to keep that seed phrase absolutely secure. You can do so by putting it on a physical device, but for me personally, that is not enough because I can very easily misplace a physical device. I can forget where I put it. Somebody could find it and go, oh, there's a seed phrase, bang, done. Especially if it's the kind of seed phrase storage device that you can readily read. So to me, a digital copy that's encrypted in addition to a physical backup is the best security protocol for seed backups. So I'm really focusing on encryption of seed phrases, which is why this is on a Bitcoin channel. So follow along with me. Now, as I mentioned, none of these articles specifically mentioned AES 256 encryption algorithm, which is what we're discussing, but they did mention other encryption algorithms that are not particularly safe, provided the computer is not infected, then it is safe. But if the computer is infected by malware, those encryption algorithms are not safe. If anyone has any other information about this and that proves me wrong, please list it in the comments below because I need to know that because I have a Mac. Now, I am not an encryption expert, nor am I a Mac security expert, so please keep that in mind. But I think the things I'm going to show you today can help you keep your information, particularly your seed phrases, safe and secure on your Mac or even in a cloud storage system. But please let me know if I'm wrong. So today's video is a follow-up to my previous seed phrase security video for the Mac, which was 1 or 2 videos ago. Today, I'm going to show you how to generate and use your very own encryption key on the Mac. And I'm going to give you 2 free third-party alternatives that you can use to encrypt files on your Mac as well. These 2 applications are called Encrypto and CryptoFile, and they are both available for free on the App Store. First, let's take a look at how to generate your very own encryption keys using the Mac terminal. To get to the Mac terminal application, you need to press Command and Spacebar and type in terminal or TERM. It will pop up, press Enter, and that should launch the terminal application. I'll see you on the inside. Oh, before we go to the terminal, I went over the terminal application's built-in encryption features in a previous video, like I mentioned. So check that out if you're interested. Today, what we're going to do is use the random number generator built into the Mac OS to generate a random AES-256 encryption key along with a password of sorts. I'll explain it. So let's go ahead and take a look at the terminal. Okay, here we are in the terminal. Yours is going to look a little different because mine has this fancy prompt that I've set up. You should probably set yours up just like this. Anyway, in order to generate a random AES-256 encryption key, which we're going to then use in a different command to encrypt a file, you have to start with this command, and I'm going to paste this in. It's in my clipboard. It's right here. Okay, open SSL space ENC stands for encryption. And then the type of encryption you want to generate, AES-256-CBC. That's a specific type of AES encryption. Then the letter K for the key to generate a key, and secret uses a database of random numbers. I'm not sure what the P and MD are for. And then SHA-1 is the technique or the hashing method that it uses to generate that key. So I'm going to press enter, and there it is. This is pretty easy. So when you execute that command, you generate 3 different values. You generate a salt value, which I'll explain later. We generate an AES-256 encryption key, and then we also generate what's called an initialization vector, which is sort of a password. Okay, so we're going to use the key, and we're going to use the initialization value right now. The salt value is used to create the key, and that's already been used. And then the initialization vector is used in the encryption that the key is used for. So the key and the initialization vector are used in the actual encryption process. Now, remember I said that this initialization vector and key are used in the encryption process. That means both numbers are absolutely critical. You cannot lose the key because you will not be able to decrypt the information you're going to encrypt. And you cannot lose the initialization vector, okay? So please store those responsibly and do not lose them. The next command we're going to use is the actual encryption command. We're going to use these values to encrypt a file. So I'm going to paste that in here again. And there we go. It's an open SSL command with the encryption code right next to it, or encryption flag or command, I'm not sure how you say it. Then AES-256 CBC encryption. It has a salt value built in. And then this is where you put the file that's going to be encrypted. And then the out value, or the out file after it's encrypted, is the name of the file and the location of the file after it's been encrypted. And then you input your key and you import your initialization vector. Okay, so let's do that. All right, I'm going to paste in my AES key and my initialization vector, and then I'm going to grab a file and put that in there as well, just to show you how that's done. So I'm going to double click this, copy that, and then I'm going to back up here, clear that out, and paste the key. And then I'm going to double click the initialization vector, copy that, and then delete this dummy text, paste the initialization vector, and then I'm going to go up here, and the destination file I'm going to leave for a moment, and the input file I'm going to delete. And then I'm going to just drag a file that I want to encrypt into that spot. I've located the file, and now I'm going to drag it in here. And hopefully, yes, there's the file. My fake seed phrase. There we go. And then the out file, I'm going to delete that dummy text there. I'm going to drag the file I just did, but I'm going to change the name in the terminal. Right now, the encrypted file is called myFakeSeedPhrase.txt. So I'm going to change it to my new seed phrase, txt.enc. So I know that it's encrypted. And that should do it. Hopefully, I'm going to press return and see what happens. And that's it. I'm going to show you the file is right here. My new seed phrase txt.enc. It's in the same folder that the original file is in. Both files are in the same folder and easy access. And now I can delete this one, and this is my new encrypted file. That's it. Pretty simple. So how do we decrypt a file? That's another command, and I'll show you that right now. So in order to decrypt that particular file that we just encrypted, it's just another command, and I'm going to paste it in here from my clipboard. There we go. Open SSL, encryption, decrypt, as opposed to encrypt, AES 256, the in file, and then the out file. And then, of course, you have to put in your AES key and your IV, and it will decrypt the file. That's it. Pretty simple. I will put these 3 commands in the description below so you have easy access to them. And that's how you create a custom AES 256 CBC encryption key and initialization vector in the terminal on the Mac. Okay, now that's pretty complicated and it can be a bit intimidating. So let's turn to a free alternative that I found on the App Store, the Mac App Store, that is really simple. Let's take a look at that. It's called Encrypto. Okay, here we are in the Mac App Store, and we're going to search for that app, ENCRYPTO, Encrypto. There it is. Mine says open. Yours will say get. So click on that, download it, and install it. Well, it'll be installed, then double click it, and I'll see you after that. Okay, this is what it looks like. It's about as simple as it gets, like ridiculously simple. This is the entire application. It doesn't have any options for you to select or settings for you to set. It's just this. Okay, super easy. What we're going to do to show you how to use this is we're going to drag a file from my test folder to the Encrypto app, and then we're enter a password, and that's it. All right, I grabbed a file from my test folder. It's right here. Going to drop it, my fake seed phrase. It's a JPEG. There it is. And I'm going to enter a strong password. Again, now this does not have an initialization vector. It might have one, but it's hidden inside the application. It doesn't have a salt value. Again, it might have one. It's inside the application, but you don't know what the encryption key is. So the downside to using this application, it's a compromise. That is convenience and security. You can't have super convenient and super secure. You can't have super convenience of leaving your crypto on an exchange and have it be super secure. Well, while the security level of exchanges are very high, we all know what happened to the people who left their secure crypto on FTX, Voyager, Celsius, and various other platforms that collapsed in 2022. So this is extremely convenient way to encrypt files, and I use it, but I don't know what the encryption key is. And if someone discovered the encryption key or was able to figure it out or hacked into Encrypto's software or their database or something, or even the developer gave away the encryption key, every file ever encrypted by every single person that had downloaded this app would be at risk. You got that? Every file by every person. Because if I encrypt this file and I send it to a friend, all they have to do is download Encrypto and know the password. They slide the file over, decrypt it, enter the password, and boom, they're in. Okay? Super convenient. But that means that it uses the same encryption key for every single person. Okay? It doesn't generate a random encryption key every time to use a different key for different files. And it certainly doesn't use a different encryption key for every download. So that's the trade-off, convenience and security. So let's go ahead and enter a password. This password is not going to be very secure. And here you can put a hint My hint is longer than my passphrase. That's not good. All right, I'm going to encrypt the file. Wow. And then you can save it. Save it wherever you want. Boom. Done. That's it. And then you start over. And in order to decrypt the file, you just take the file, drag it into Encrypto, enter the password, and then save it. Super easy. All right. That is almost too easy. It's so convenient. It's amazing. Let's look at another level in another application. It's called CryptoFile. Again, it's available on the App Store. So let's jump back into the App Store, download that file, and we'll take a look at that one. It's a little more, it's not as intuitive, a little more difficult to figure out, but I'll walk you through it. Okay, here we are back in the App Store. And let's go ahead and search for that second app. It's called CryptoFile. There we are. Again, yours is going to say get. Go ahead and get it. It will install it. Double click it, and I'll see you on the inside of that app. All right, here's the CryptoFile app, and it is not very intuitive. So this is how you drop a file, and then you can click the encrypt button, nothing happens. You click the decrypt button, nothing happens. Here's a key area, no idea what that is, and an extension area, and I'll show you what that is. I do know what the key area is. I figured it out, but it is not easy to learn, so I'm going to walk you right through it. So in order to encrypt a file, let's grab a file and drag it in here. Okay, so I dragged and dropped a file into this application, and now I want to encrypt it, so go down here and press the encrypt button, and nothing happens. Well, maybe I should select a key. Well, there's no key in there, so how am I supposed to do this? All right, let's go down to settings. File name extension. It will not work unless you have a file name extension for the encrypted file. You can use .enc, you can use .encrypted, you can use whatever you want, really. I just chose something that made it obvious that it was an encrypted file, and that is the AES 256 term there, 256. You could put ENC or whatever you want, and you can add that as a file extension, but you need a file extension name. I'm going to delete that and keep it nice and clean. We also need a key. So, I don't have a key there, so it's not working. So we have to generate a key. That turns out you have to generate a key. And the middle area is where you generate the key. So this is where you encrypt. This is where you generate an encryption key. And this is where you enter the key and the encryption extension, the file extension name. Okay, so here we are in the hashing area. That is where you create an encryption key. Now, there's a whole bunch of numbers here that look like encryption keys, and in fact, you could use this as an encryption key, and you could use this as an encryption key, but they're not very secure. So this is a hash of whatever text you have in this area. Of course, there's no text here right now. So the sort of standard hash that they have built into this application is represented right here. And this is a hash or a encryption key created using a password. This jumble of letters and numbers down here stands for password base key derivation function 2. This is the key you want to use. This is just a hash or a conversion of text to a set of numbers. And this set of numbers does not change. It's always the same length. No matter what text I put in here, let's say I put the word password, then the numbers in these hashes doesn't change. And this one too. But every time I type the word password in here, I get the exact same hash. So this is called deterministic. That is, this same word, if I type it over and over, creates the same SHA-256 hash. When you make a key, you want the key to be unique. And this certainly is not a unique encryption key. This key is unique because we're going to add a salt value and we're going to add iterations. Okay? So we're going to take any text, it doesn't matter, but this is your password that creates the key. You need to remember this password and keep it securely. So we're going to put in this is my password. And you saw all these values change. This is the key we're going to use, but we have to add a salt value here, and I'm just going to put in a bunch of random numbers. I'm going to get those off the clipboard. All right, I'm going to paste this off the clipboard. There's my salt value. That is 32 digits. It doesn't have to be that long. You can certainly use something that's 16 digits long if you want. I don't know how many digits that is right there, but it doesn't have to be that long. The longer, the better. The salt value is used to create the key, okay? It adds randomness to the key creation algorithm. The iterations is the number of times this salt value is repeated. How many times is the salt value added and then redone and then redone and then redone and then redone? So security experts recommend an iteration level above 10,000 for security, but for more secure items, they recommend much higher. I've seen, for instance, I use a password manager called Bitwarden. The the iterations value in Bitwarden is 600,000. So let's use 600,000 and watch the numbers change. There we go. The iterations is the number of times that the salt value is applied to create the key. And the higher the iterations, the more powerful the computer system is that's needed to crack the key or break the encryption algorithm. This is our encryption key. You cannot lose this key. Now, you can lose the iterations, you can lose the salt value, you can lose the text if you have the key. If you don't have the key, it's actually pretty easy to recreate if you have your password, your salt value, and your iterations. So it's up to you, but I'd recommend keeping all four. Keep everything. We're going to copy this value. We're going to go to the settings area. We're going to paste it into the key area, and then you have to press add. It took me a while to figure that out. Then we go back to the file that we're going to encrypt. We select our key, we select our extension, we select encrypt, and we click start, and it says, where would you like to save it? I'm going to save it in my test folder, and we're done. That's it. Now, there is one other way that you can create an encryption set or encryption keys with a salt value and initialization vector, and that is using Python. Now, I am not a coder, and Python is a coding language that's very popular across security spaces these days. It's a very common language that people use, but I don't know how to code for Python, but I do know the commands to create encryption keys. So you can sign off now. Thanks for watching if you don't want to see that, but if you want to see that, I'll show you how to do that. It's really easy and really quick. Okay, here we are at a site called Python-Fiddle.com. I actually contacted the developer myself, and he responded right away. I was super impressed. I asked him about the security of this site. He said, all of the coding is run locally. That is on your computer. It is not run on a remote server. It is not run on his server. His server provides the service to be able to run the code locally. It is run in your web browser locally. So it is not sent anywhere. So it apparently is secure. This is the window that you use to run the Python code. And I'm going to delete the code that's there. And I'm going to paste quite a long piece of Python code in here. And what this is, as far as I can tell, you set the iterations, you enter your own password, which is right here. And then it also generates a salt value for you, and it will give you that value at the end. So let's go ahead and run this and see what we come up with. I'm going to press the run button here. And there we are. It's a password-based key derivation function to key in hexadecimal format, which is what we want right here. And it goes a little bit longer than that. And then this is the salt value that we could use. And then we know the iterations, which are 500,000. And you can change that before you run the code to whatever you want. And you can also change your password. That's not a very secure password. So this is basically a really quick and easy version of the CryptoFile app. It's sort of a complex look under the hood, but it does the exact same thing. There's another series of commands that I can give you that do something similar, and where the system, I'm going to delete this. Actually, I'm going to refresh the page, and there we go. This command is similar, but what it does is it asks the Python database to create a password for you. So it will create a password for you, a salt value, and a key, a PBKDF2 key. And I will copy and paste that, and I'll be right back. I have the commands. I'm going to paste that in here. And again, iterations, 500,000, and SHA-256 hash function. You can change the iterations to whatever you want. It's going to generate a password for us. It's going to generate a key, and it's going to generate a salt value. So let's go ahead and run this. Here we go. Password, key, salt. And there we go. Random password. Very good. Hexadecimal PBKDF2 key, which extends beyond the page here. And then the salt value. And we know the iterations is 500,000 because it's right here. That's it. Thanks for hanging in there. So this video was made in response to the recently discovered Mac security vulnerability. I don't know if the AES encryption function of the Mac is secure or not. Again, it was not mentioned in any of those articles that I've read. So these are some alternatives that I think are safe. But again, if you have information otherwise, please let me know. Thank you so much for watching. Please keep your seed phrase safe, and the things I'm showing you are designed to help you do that. Thanks again. Oh, don't forget to like and please subscribe to the channel. I promise not many more security videos, maybe one more, but mostly Bitcoin. Okay? Thank you. I'll see you in the next video.